All right, we're up to number 14. This one is about integration of a product. So here's the question, trying to integrate this thing. And just for your reference, we've got the formula sheet for methods there as well. So press pause, give it a go. So the most common mistake students make when they see integrations of products is they think, oh, this is U and this is V, and I'm down here on the product rule. Okay, but remember, product rule is only for differentiation. Okay, so we're not using any of these things. All of these formulas are for differentiation, and so are all of these. You only have a very limited number of formulas for integration. So I really stuck just with these 5 formulas, and none of these seem to help me integrate this function. So all I'm going to do is make it look like one of these formulas. Okay, I'm going to make it look like this one. So I'm going to do a bit of index laws and a bit of expansion at the same time. Okay, so I haven't integrated it yet, so I still leave the integral there. I'm going to change the square root of x to x to the power of a half using your fractional index laws, and just write these other ones the same. Okay, so a bit of index laws. Now I'm going to expand these using distributive law. So multiplying these two, so I'll end up with 2x to the power 3 on 2. You can think about that, how that happened. Power of a half plus, there's no power there, so it's really a power 1. And then do the same thing to this one. So plus x to the power, well, a half plus 2 is really a half plus 4 on 2, so that gives me 5 on 2 as my power. So now I have a function which I can integrate because it's just 2 terms using that power rule at the top of the formula sheet. So add 1 to the power and divide by that same new power. Okay, so now I'll do it. The integral sign disappears because now I'm actually doing the integration. So add 1 to this power, 3 on 2 plus 1 gives me 5 on 2, and I'm dividing by 5 on 2. Plus x to the power, 5 on 2 plus 1 is 7 on 2, and I have to divide by that new power as well. Okay, plus c. So I've actually done the integration now. That'd be fine, I'd be able to use that, but most questions require you to give it back in the form that it was given to you. So the question gave us radical signs, so square root signs. We need to convert it back to those sorts of signs. Okay, so again, using fractional index laws, this is the square root of x to the power 5, still on 5 over 2, and this is the square root of x to the power 7, still on 7 on 2. Okay, I'm dividing by fractions. The way I divide fractions is I multiply by the reciprocal of the fraction. So you can see this 5 on 2. Dividing by 5 on 2, that's going to mean multiplying by 2 on 5. Okay, so it'll be multiplying by 2 on 5. And then the same one, dividing by 7 on 2, is the same as multiplying by 2 on 7. Okay, so just cleaning it up a little bit for square root of x to the power 5 on 5 plus 2 square root of x to the power 7 on 7 plus c. Just remember that there's really a 2 here as well, the square root. So when we have square root of 9, there's no 2 there. Okay, but if we have cubed root of 27, we have that little 3 there. Okay, so just remember that that little 2 on the denominator of the power, we don't actually write it on that square root sign. Okay, so the general sort of principle for doing all these sorts of problems is make it look like something that you can use the formula sheet for, and don't try and invent any of your own rules. Okay, so hopefully it's all good. If you've got any other questions, feel free to send them through and I'll help you out. Okay, good luck.